An antiderivative of the function f of x, which is equal to cos x minus cos cubed x, is capital F of x, which is equal to a third of sine cubed x. Use this fact and the fundamental theorem of calculus to find the integral from pi on 6 to pi on 2 of cos x minus cos cubed x dx. Well, let's understand the question first. An antiderivative is a function that differentiates to give the function you're thinking of. So that must mean that the derivative of this is equal to this. So we know what an antiderivative is. Next, let's think about what the fundamental theorem of calculus says. And I think I might just write that down. The fundamental theorem of calculus says if f is an antiderivative of f, small f, then the integral from a to b of f of x dx is equal to f of b, capital F of b, minus capital F of a. Oh, and we can write this as f of x from a to b. That's what the fundamental theorem of calculus says. So basically the fundamental theorem of calculus is just telling us that we can do integrals the way we already know we can do integrals. Well, that's good. All we need to do is just integrate. So let's see. The integral from pi on 6 to pi on 2 of cos x minus cos cubed x dx is equal to, so we write this and we copy our a and our b, pi on 6 to pi on 2, and inside these brackets we put an antiderivative of cos x minus cos cubed x, and according to the question that's a third of sine cubed x. So that would be a third of sine cubed of pi on 2 minus a third of sine cubed of pi on 6. So sine of pi on 2 is 1, so that would be a third times 1 cubed. And sine of pi on 6 is a half, so that would be a third times a half cubed. So I've got a third times 1 cubed, which is just a third, minus a third times a half cubed, which is a third times an eighth. So that's a third minus a third times an eighth, which when I put it all into my calculator comes out to, in fact I might just write down the answer, it comes out to 7 on 24. And that's the answer.